Welcome back to Industrial Problem Solving. My name is Dave Roysum. In this clip, I show another one of my most favorite of the Street Smart tools, the Shape tool. It is not only useful for some of your most challenging problems, it is a front and center tool for some problems such as bagginess. I also throw in a bonus technique or philosophy at the end that should help speed up many of your problem-solving efforts. The method of the Shape tool is beguilingly easy to state. That is, the shape of the problem must resemble the shape of the cause. Before we begin, let's expand on a technique we discussed in an earlier module. During a brainstorming segment, the first rule is that no critique is allowed to begin with, even if it counters the known laws of physics, such as gravity. The participant is allowed to freely expand on their idea without censure or even comment. Obviously, however, some ideas are better or way better than others, and some ideas are so bad that they may even violate the laws of physics. So, how do we prevent ideas, which are always assumed first to be good to begin with, from becoming bad when they pass through the meeting room doors and out into the plant where they cost you time and money? The answer is the Shape tool. Yes, maybe science or statistics might screen some bad ideas, but in the real world, our problems are often beyond the reach of science or statistics, or that they may not offer ironclad conclusions. However, the Shape tool can be used in almost any case where shapes are known. It is a must-have, number one, go-to tool for bagginess, as we will see shortly, as well as many other truly tough problems. So, let's start with a very common problem. Baggy edges, plural, 2 edges. Question number 1. What is the shape of baggy edges? Question number 2. Which of the following are not good candidates? Think about this. Take your time. Pause the tape. Resume play only after you have crafted your answers. Okay. So, what did you come up with? The answer to the first question is that the shape of baggy edges is smile or frown. It is a frown-shaped tension profile. However, as my 5,000 Web 101 students also know, it is a smile-shaped length profile. As such, coder streakiness cannot be a root cause because it doesn't have the correct shape. Streakiness is, well, streaky, and in no way resembles smiles and frowns. Yes, streakiness could make the problems worse, but it cannot make them. Streakiness is neither necessary or sufficient. Similarly with tension. Yes, tension is a factor in many, if not most, web handling problems. Also, knowing whether more or less tension is helpful is, well, helpful. But tension does not have the correct shape. Tension is not sufficient in itself. You are missing something vital. Similarly, misalignment is taper-shaped. A single misaligned roller in no way makes a smile or frown shape. Yes, the reader might superpose two misalignments in opposite directions, but such explanations are not parsimonious and thus not appealing, even if possible. Finally, deflection. Deflection has the right shape. Thus, deflection is eligible by shape alone. Whether it is a good candidate or not is a secondary discussion. It passed this screen. Yes, the shape tool is powerful and flexible. Perhaps as powerful and flexible as science or statistics. Indeed, it can even be augmented by science or statistics if you wish. It is flexible because it can be applied across the width, as we just did, with time or in the time domain, as we do with FFT analysis. Still, I must stress one very important caution. That is, you must absolutely know the shape. Trusting an instrument is not good enough, as we have belabored many times in this problem-solving course. Just because an instrument can't see a shape doesn't mean it's not there. It may well be below its threshold of resolution. A common example here is thickness profile and winding. We often can't measure the variations that cause winders grief because the web is thin and the variations are even thinner yet. Conversely, just because an instrument sees a shape does not mean it is so. It's not unusual for a shape to be built into an instrument due to edge effects, misalignments, or cross-sensitivities. I have used the word profile here and often elsewhere in my Web 101 course modules. Profile is a very powerful troubleshooting word. It allows us to get started without being too specific in our language, provided that we know the shapes, which we often do, especially in the case of outcomes such as problems and customer complaints. Simply stated, profile is the variation of something across the width of the web, daughter role, parent role, process, or whatever. This something can well be whatever you can measure or otherwise know. Thickness profile is probably the most common measurement. Problem profile is also usually well known. Problems often favor one edge of a machine or both edges of the machine as an example. However, profile can be any property varying across the width, but relatively stable with time. The two most common profile shapes are smile-frown or taper. Note that how they actually appear on the web may vary slightly with the idealized shape. For example, a fan-shaped wrinkle profile is a smile-frown in disguise. All you need to do to verify this is to take the absolute value of the wrinkle angle profile, and you will see that is the case. Similarly, a problem on one edge may well be a full taper, that is, thresholded. In other words, not bad enough to see elsewhere. We have time for one more tool or technique. It is what I call the make it worse tool. The reason is that making a problem worse gives you the same information as making the problem better, but is usually easier. Again, a tool for the lazy problem solver. How we do this in the field depends on the situation. For example, I may start out in the comfort of a meeting room and ask people, how could you make it worse? Everyone gets a vote. Here, we let the participant think that it's a silly game the consultant is playing and they will humor him. Well, who knows? They're just playing a game, right? However, it is not a game. I am deadly serious about knowing the connections between some variable and the independent variable of the problem. I don't care, at least initially, whether the information can be practically applied or not. That is censoring information, and that is not permitted at this stage. The reason for this game is that people are so ingrained into the plant philosophy that defects are bad, that we have to work extra hard to pull it out of them. In some cases, I've even made it a contest and paid the winner to make the biggest, baddest defect they've ever seen. In some ways, this is similar to the exaggeration tool we talked about in one of the first of the Street Smart tool modules. However, strictly speaking, the exaggeration tool was used to reduce trial time. In the making it worse tool, we choose the bad direction in addition to making big moves. What we want to make clear during these problem-solving sessions is that not only is it okay to make defects, that is what we want. An attitude like this is essential for bagginess troubleshooters, as we discussed in the 24 case histories in the Web40110 series on this all-web handling channel. It is also helpful in many other tough problems. The only limitation is that while we do want to break the web, we don't want to break the machine. But that is a very low risk due to the cautious machine design and even more cautious machine operation practices. Thank you so very much for joining me in this continuation to the industrial problem-solving process. I hope I've made the case that the shape tool and its many variations is one of the most powerful ways to most quickly figure out some really tough problems. Stay tuned for the next module where we finish out the Street Smart section of this course and move on to other must-know topics in industrial problem solving.